These sets include 10 wooden three-dimensional geometric solids painted in blue. The solids in these sets are a sphere, ovoid, ellipsoid, cone, triangular-based pyramid, square-based pyramid, cylinder, cube, rectangular prism, and a triangular prism. It also includes 5 planes and 3 wooden bases to hold the curved.
The Montessori curriculum starts out in geometry with 2 parts. One is for three-dimensional figures, which are the geometric solids, and then the other part are the plane figures, which is the geometric cabinet. So we're going to talk about the geometric solids right now. The initial solids that the children start out with are, there are 10 of them. And with the younger children, what we're doing here is we're interested in kind of the sensorial experience of having the children feel the solids and talk about the solids and name the solids and learn the names of the solids. So this is really all, these are all of the objectives that we're going to be doing with the geometric solids. The solids that are in this set are what we normally would do is start out with solids that are more easily recognizable to the child. So, for example, the sphere, and we would talk about the sphere. We'd hold the sphere, we'd kind of roll it around in our hands, we'd gently roll it around on the rug and show that it moves around and that it looks the same any way you look at it. So you're, again, talking about this object, talking about what are the properties of it, what doesn't it have? Well, it doesn't have any flat surfaces at all because everything is round. And it's very smooth and it's very even. It's like I said, the same any way you look at it. So this is called a sphere. And then we would take another object that's very similar to what children see in the real world, and this is a cube, and they've played with cubes, blocks when they're little, so they're very familiar with what this shape is. And now we're introducing the fact that it has a name, and the name, its real name is cube. And it's different, again, than the sphere because the sphere, it rolls. Although this is the same on any way you look at it too, it's very different in the way that it's the same because it has flat sides. It has a series of flat sides, and all the flat sides are the same. And then they're divided, or they're connected by these lines and these points. So we're not going to be naming all of those right now. We're just going to be talking about it and have the children feel both and really get a sense of how does this feel? How does this feel? How is this different? And what are these sides called? Well, they're called squares. And a cube, all of the sides are squares. They're all the same. So we take our time and talk about all the properties of a cube. And then another similar shape that the children see all over the place is a cylinder. Soup cans, so many things that we see. A glass of water is shaped like a cylinder. So here we would show the properties again, that the cylinder is round, kind of like the sphere on part of it, but then the other part of it is flat. But unlike the cube that has a square surface, a cylinder has a circle for one of its surfaces. So this cylinder over here has no surface, and then it has 2 surfaces on the end, and those are called bases. So this is a circle, and this is a square. So on the end, and again, just having this great discussion about what the differences are, how do they feel differently, and then the last part would be with the older children is actually adding the names so that the children can see what the labels, what they look like. Okay, you do a lot of 3-period lessons with this material, So you do a lot of 3-period lessons with this material. This is a sphere, the first period. This is a sphere. This is a cube. This is a cylinder. This is a cylinder. This is a sphere. This is a cube. Show me, second period, show me the sphere. Show me the cylinder. Show me the cube. Third period, what is this? Cube. What is this? Sphere. What is this? Cylinder. Orally at first, and then have them match labels. Cube, sphere, cylinder. Okay, and so we'd start out just with the most basic shapes, the shapes, the most familiar shapes, and then again, this is one that's pretty familiar. This one is a cone, so maybe take away the cylinder next time. Just do those 3 shapes, exactly the same lesson. You could add back the cylinder and do 4 shapes. And then at the very end, when the children got really good at all of this, we're going to add all the shapes so that they are able to name all the shapes. Okay. Okay. So the name of this shape is called an ellipsoid. And I remember this because it looks like a football. It's got these kind of pointy edges, but they're not really points. It's still rounded on all edges, but it kind of has this kind of looping movement this way, but it's very smooth to roll it this way. So this is an ellipsoid, as opposed to this shape, which is very similar. It's very similar, but while this one kind of looks like a football because it's the same on both edges, on both sides, this one is very different. It's more rounded on one side than it is on the other, and this is more like an egg, and it even has the name for egg in its name, which is ovoid, because in Latin ovum means egg. So this is an ovum, ovoid ellipsoid. 2-dimensional figure here is an oval, and the 2-dimensional figure here is an ellipse. But in 3-dimensional, you add the ending oid at the end. So ellipsoid and ovoid. These are also similar because these are both prisms. A prism is a shape that has a rectangle for part of its bases. So these are both rectangles. Both of these shapes have rectangles here, but the base here is different. One is a square, one is a triangle. And what makes a prism is that it has the same base on both sides. So there's a triangle here, a triangle here. This one has a square and a square. Okay, so this is called a square-based prism, and this one is called a triangular-based prism. Oh, sorry, prism. A triangular-based prism there. The last 2 shapes, again, very similar, but they come to a point, and the children will say, oh, those look like the pyramids in Egypt. And you say, yes, that's exactly why they're called pyramids, because this in geometry is the name of a shape that has a flat surface on its sides, but it has a wider base on one end, and then it comes to a point on the other end. So, triangular-based pyramid. And this one is a pyramid, but instead of 3 sides, it has 4, because the bottom of it, the base of it, is a square. So this is a square-based pyramid. Okay? So again, you'll see that these are very similar from this side, but they're very different from this side, and they're also very different from this side. Okay, so the more you can talk to the children, same here, difference between the prism and the pyramid, here, here, and here. Okay, so this is these can be done as a group lesson with all the children in a circle. When you're getting ready to go to lunch, you just name the cylinders, name the shapes. The cylinder, you name this. Sorry, let me try that again. So naming these shapes can be done during transition times. They can be done during formal geometry lessons. So these are the basic shapes that start out with three-dimensional geometry. And then as the children get older, these shapes will get larger, and they'll also become hollow, so that you can do experiments of volume with them. But at this point they're solid, and that's hence their name. And this is a lot of fun, just naming these and feeling them, coming up with all the things in the real world that look like it. You can make a book of all the cylinders that you see. They can cut out cylinders in magazines. They can cut out triangular-based pyramids or square-based pyramids. Look for architectural examples, or in the grocery store, what maybe fruits and vegetables might look like. A lettuce looks like a sphere, for example, certain kinds of lettuce. So ice cream cones, what kind of food can you find? An orange sphere looks like an orange or an apple. So this is an egg. So, I mean, there's lots of ways that you can make the connection between the real world and these the names of these shapes.